Okay, so hi everyone. My name's Ruben Miller. I'm the product owner for ThinEdge. As you've probably seen me kind of around, oops, let me move that, doing a lot of the demos. So I wanted to give a bit of like news and updates to really show, also like focus a little bit more in technical detail on a really cool, exciting upcoming feature. But just in case, if you kind of don't really, you need a bit of like context to get us, get you familiar with what we're doing. So ThinEdge, it's all about basically making it easier to manage your IoT devices in the field. So this is making it easier to manage from a device management point of view, like installed software, firmware updates, but also then be able to allow you to send your IoT data to the cloud. So we don't try to kind of mandate what cloud that is, because it's a very diverse kind of setup most of the time. So maybe you want to do Comlossi to Azure, AWS, whatever, doesn't matter. You can kind of achieve all of that with ThinEdge. So most of the time, you have ThinEdge installed on your box, have a cloud connection, and then you interact it with your local applications. So just in case if you haven't kind of been keeping up to date with what we released at the end of last year, so we had a lot of new features. So 1.7 dropped, where we included log plugin support. So that meant a huge improvement to what we can kind of provide to access logs on a device. So most notably adding kind of general D support out of the box, which was a great addition, but also like dmessage for those technical Linux kernel bugs that you can kind of check on. But we also added like support for publishing measurements with units, finally. And also continuing improving the hardware security module interface to make it even easier to use your device using like TPNs, etc. And also we're continually doing always like small improvements, like, finally supporting connecting to the local MQTT broker using username password. So again, we have a whole team behind, which is continually developing, so you don't have to do that. So for the upcoming features, so we're weeks away from the next drop, which has some really, really awesome features. So the most notable one is basically extensible mappers. So this is basically allowing you to do your own data flows, and I'll do a whole presentation on this after this slide, but it's a really, really powerful feature. With the Comlossi MQTT service going into GA also at the end of this quarter, we'll also have full support for that. So that means you can send data on custom topics, also using ThinEdge. So that means you can be really flexible with how you design your kind of IoT solutions and then publish to custom topics, which is really, really flexible. Then a big kind of shift, which emphasizes our any cloud kind of setup. We want to basically enable all of our users to configure a generic MQTT bridge. So this means you can connect to any MQTT broker in the cloud or locally, or it doesn't really matter. So, you could integrate ThingsBoard now and all of the different kind of other kind of solutions out there. We don't try to put a limit on it needs to be either Comlossi, AWS, or Azure. So I think that will be also a great feature. So for the upcoming release, the flows is really our kind of like highlight feature of the whole release. And we've actually been working on this for a very, very long time. So I think we started probably like exploring the idea and collecting kind of requirements probably about middle of last year. And we've been trying to refine it over time to then have a really great feature at the end that can benefit you. So to kind of emphasize why this is kind of required. So over the years, we've had a lot of customers and they go, ThinEdge is great, I can manage all my devices and install software, fantastic. But then when it came to integrating their own kind of data model or like connecting additional sensors or something, we heard there was a lot of requirements to do like little small tweaks. So some of that could be like rewriting the data before it goes to the cloud, going, I want to add like an additional property to it, or maybe do a little like local analytics, determining, how long is a device offline or something, and then generating that and pushing that to the cloud. A lot of requests for being a little bit slimmer on the bandwidth usage. So going, hey, can we use Protobuf? And at the moment, the answer was, yeah, no, not really. Like, you can extend ThinEdge anything you like, because we have an open MQT bus, you can kind of extend it to anything you want. However, the problem was the cost of extending it. So all of these scenarios basically then resulted in, you have to create your own application, and that application needs to have its full life cycle. So you have to worry about the MQT connection. How do you buffer messages? How do you kind of reconnect? And all these kinds of things. And this is something you have to build, test, and maintain. And you have to know about the differences in init systems. And if you're going, what's an init system? Exactly. So all of this kind of things, the burden to kind of then extend it to your own business applications when it comes into like manipulating data was very difficult. So this is where flows comes in. So the whole idea with flows is, you have, let's say if you want to do one data manipulation, to saying, I want to process all events coming in and add an extra field to it. So a flow is basically taking an input. So in this case, like if you want to manipulate an event, it'll be already in an MQT format or on the MQT bus. You want to take it, do some steps to it, which, do some processing, add that field, and then output that message. So back onto the MQT bus, and then that gets published. So this kind of flow where, the number of steps you do is really up to you. So it could be a flow of one step. It's really, you can make it as complex or as simple as you like. All of these steps are written in JavaScript. So we're calling them smart functions. So it's just a bit of JavaScript that we're executing with a given interface. And we just kind of chain them together. And that's it. So with all of that, like, all of the flow kind of functionality, it's actually built into every mapper that we have. So you can kind of slot it into the Comlosity mapper, the AWS, Azure mapper seamlessly. And also if you have some data which is maybe cloud agnostic, you could also slot it into a new mapper that we have that you can start called the local mapper. So you might want to be doing some local analytics or something, go, well, it's not really coupled to any cloud, so why do I put it in the CY mapper, for instance? And then all of this has the advantage of, we could have just opened everything up and go, hey, you can do absolutely everything. But the advantage of this is we actually get to run it in a sandboxed environment. So this means you can't then say, you can kind of deploy a flow from a third party and not really be too concerned about what files is it accessing and all these kind of complicated questions. You can be sure that you're going, well, it's just inputting data like from an MQT source and then outputting something. So it's a very simple thing to kind of control as well. So with these simple but powerful kind of mechanisms. So if we look at deploying a flow to the mapper, it's kind of up to you where you deploy this. So you can deploy it to the different kind of mappers, but really what's kind of key to it is, so you can kind of couple this kind of flow definition to the mapper which is it's appropriate for. For instance, if you only have a mapping which is doing Comlosity message mapping, put it in the Comlosity mapper. So that means that when the Comlosity mapper is not running, then your flow is not running. That's it. So it's kind of, it's flexible to see how you can couple it to whatever you're liking. And again, if you don't have some mapper specific, so like a cloud mapper specific logic, then put it in the local one. That can be like the generic one. So with the flow, it's not just about, you have your flow definition, which is basically binding, what do I do? So it's hooking up the connectors. So that input, like where do I get my input for? Defining the steps, which going, what do I do with that input? And connecting it to an output. And so that steps, they can also generate 0 or more messages. So this means that with that simple mechanism of 0 or more, that means you have a filter, filter a message and going, if that doesn't, match some kind of schema, then don't publish it. So these are kind of rudimentary mechanisms are very, very powerful. And then along with that, all of the steps also have access to an additional context. So that is provided at runtime. So you have an ability to kind of have that context shared either within the script, flow level, or on the mapper level. So you can kind of decide how to kind of use that. So you can even share state in between flows. If you want to do something more complicated, like a circuit breaker pattern, when too many messages are detected, you want to raise a signal to other flows that go, oh, I should stop publishing messages or something. So it allows you to actually fulfill a lot of really, really complicated requirements in a very easy composable way. So if we look at a flow definition, so in the end, because we're thin edge, we basically, all of our stuff is in TOML, because we're written in Rust, and TOML is kind of the preferred one in Rust, but also has a few kind of niceties in the configuration aspect. So here we have an example that we're saying that this flow is applicable. It should only process the measurements from the main device. So everyone should be hopefully familiar with this. So that's the the thin edge local MQT topic. And then here I'm doing a few things to it. So I have a few different steps. So for instance, not only can you do the scripts, which is in JavaScript, but we also provide a bit of like our out-of-the-box functions, which are actually written in Rust. So for instance, for all of our message mapping and Comvosity and all of the other clouds, we have a function to add the timestamp. So you can add the timestamp exactly how we do it. So you make sure that you don't have to write your custom logic there. So add the timestamp. I want to maybe do some kind of custom logic there, no mapping Fahrenheit to Celsius. And then also apply, again, using built-in, maybe a size limitation on that message, because in MQT that each message has actually a payload limit. And if you exceed that limit on the broker, you get kicked off. So you can also do a lot of complicated, add that kind of validation logic to your flow to make sure you don't then publish invalid messages. So all of that is quite easy, and then you deploy it, and then everything is hot reloaded. So you don't need to restart services. It will just be automatically picked up, and you can carry on. So, and as I said before, that our input connectors, it's not just about MQTT, because if we were just saying, okay, everything's just viewable on MQT, they have a bit of the problem going, well, how do I process journal D messages? So, the log messages coming in from system D. How do I, react to that? So we have a few kind of basic inputs. So the probably most common one used, I would say, would be the topics. So from the MQT level, you can also subscribe to multiple topics. Or if you're going, well, actually, the data is already in a file. I just want to kind of read the contents of the file. That's also fine. Or if you want to read in from a process, you have two ways. You can either do it in a streaming mechanism. So for example, journalctl has a nice follow command, which will just stream the output as JSON messages. If I specify the output type as JSON, obviously. Or if you want to do something which is on an interval and going, well, just execute this every like 10 minutes, and then I'll process. So you can even do batching with this very simple mechanism. So we're hoping with that, you can write a lot of really, really nice use cases. So as the steps, this is an example of the JavaScript defined. So the JavaScript, we're calling it smart functions. So in the end, the main, there's just a function name that we then execute for you. And the main one, so if you want to react to messages, it's on message. Or if you want to just do something periodically, then on interval. And then we'll call those functions at those appropriate times. And then you can then process the messages. So you take in the message, decode it, because we also allow binary payloads. We don't assume that everything is, UTF-8, which opens it up for applicable uses in Protobuf and all those kinds of nice things. And then you produce a message output, and we will publish it for you. You do not need to worry about MQT subscriptions. We do all of that for you. So it means that that logic is super simple. So basic, you don't need to worry about reconnections, anything like that. It's all simplified for you. And maybe it wasn't obvious, but because everything's written in JavaScript, that is CPU agnostic. So there's nothing to really compile. You can deploy the same flow on any Linux device. You don't need to worry about the CPU architecture running on that device, whether it's ARM, AMD 64, or whatever. Doesn't matter, it's the same thing. And because we're talking about the JavaScript stuff, we're talking kilobytes in size. So The deployment size is small. It's easy. I don't need to worry about anything complicated. So I want to give a few use cases, then I'll demo something live, so it's not just a presentation about the things that should exist. We can show it does exist. So one of the classic use cases is for like edge analytics. So we have already a few example flows that we have a certificate alert. So if I want to maybe monitor locally on the device, so in this example, we're using the TED certificate kind of monitoring that, but you could also extrapolate that to examples where communicating with a PLC usually requires a certificate. So maybe you want to monitor that certificate to know that when you will lose access to the PLC because your certificate's expired. In normal situations, you want to have certificates renewing, but life happens and there's always bugs, and then you might then realize, oh, the renewal process doesn't work or is failing for whatever reason. Then these kind of mechanisms is a fallback to go, oh, something didn't work as properly, I can be notified. We have a log search detection, which takes the journal D messages in and then does some statistics on it going, how many log messages are receiving? Is that above a threshold? Yes, no. You can do filtering on that. You can do that by info, debug, warning, error, whatever you want. And it's also quite powerful. And with uptime, if you maybe want to track, how well is your device connected to the internet, that you can use statistics there to then monitor the health status of the cloud connection and then build a percentage, how many percent am I on over a period of time, but also then record the interruptions. So how many times did I flicker to offline, then online again? Because that is also a very important symptom to kind of recognize if you're having like a flickering device, because that can then detail that you have maybe problems with your mobile provider or things like that. So the next case is doing like bandwidth reduction. So if you're on a mobile device, you have metered data basically. So you're usually trying to minimize that data as much as possible. So one way of doing that would be then to use Protobuf as a encoding mechanism. So instead of sending everything in JSON, which is then UTF-8 encoded text, that you want to send Protobuf messages, you could send binary messages like just using your own binary encoding if you really want. But the Protobuf offers a very descriptive way to describe your data. And it's a formal schema that then the thing intercepting or like reading the message on the other side can then easily parse it and then do something and convert that to comm velocity. We have multi-cloud instance, so we also have a things board example, which is a full-featured how do I connect to things board. So it's basically another mapper to do the full kind of send telemetry data, but also react to commands. And also a little bit, if you saw the demo on Wednesday last week or this week, you would have seen even a Sparkplug B decoder, which is all running pure from flows on the device to convert, the PLC information, which might be published in Sparkplug B format, that we could actually translate that to comm velocity then messages, or actually thin-edge messages, and then that could be published to whatever cloud that you have configured. So with all these flows, like when you're building a flow, generally you want to kind of parameterize it. So not every device will be configured the same. So, for the alerting for the certificate expiring, on one device, you're going, well, I know this one's problematic, so I need a lot of time because, maybe my service crew aren't so reactive, so they need like 6 weeks out before, something expires to then have enough time to do that. That might be then region specific. So being able to do the flows, you can also then tweak specific values, which is up to the person writing the flow, saying, hey, I'll allow these parameters to be tweaked by users. So that could also be a device-dependent configuration, which is also very powerful if you're doing a whole fleet of devices. Being able to configure the exceptions is super useful. So that's enough of slides. Let's actually, I already have an open tab. Let's look at this stuff in real life. So I have running a thin-edge in the attached demo container because it's really useful to show all of the features at once. So this is the same device. I'm just using the split screen. So on the right side, it's showing the alarms because I'll be triggering some alarms via some local analytics. So with all the flows, like anything on thin-edge, we have a great software management plugin. So it was like, hey, let's create a software management plugin to then handle the life cycle of flows. Easy. So here we can already see we have a lot of the COMLocity because I'm connected to COMLocity. So all the flows there, which are built in. And then I also have a lot of flows which I've just deployed to my device. So I could then uninstall them, update them, or whatever. So here we have a certificate alert. So here I'm just going to present a new feature of COMLocity. It's not yet officially available. So I could kind of edit these parameters and do that on the terminal, but that looks a little bit, complex for some people. So I'm just going to preview subtly the parameters feature. This will be coming, great feature, but I won't explain too much about it. So the key point is here, I want to change the threshold for the alarm. So I'm going to change that I want to receive a warning at actually, let's say 900 days out. A little bit fictitious in this example, only because my certificate is already valid for 365 days, so I just need to do something about that. You can see already it's generated an alarm on the right-hand side. It's given me a very descriptive, hey, the certificate will expire in 900 days, because that's just what I configured it to. And then we can see here, expires soon, but because I've configured it, going, well, actually, this is kind of like the pre-warning. You don't need to get worried yet, but it's enough information to say, hey, monitor it. Then over time, oops, sorry, let me just reload that. Over time, if we want to go, let's do, 370 or 470, doesn't matter. So the next kind of interval comes in and go, actually, no, this is critical. You need to do something now. Then you can see here, it's updated that. So it's changed it to a major alarm. So you can then go, oh, I really need to do something now. I can't delay it any further. And then we can always change it back to then, clear all of the limits back to where they were. And then the alarm will also get cleared. So in the setup, because this one takes a little bit longer, I'm just going to change the log flow as well. So with the log search, using journal D to do some statistics, and then it will kind of then generate some alarms based on, are there too many logs happening? So that takes a little bit more time, I think 15 seconds. I configured it just for the demo. And we can already see, hey, it's come up. Oh, I'm being spammed with too many logs. Why that's important? Flash wear. So if you have this writing to disk, this will then eat your disk lifetime or your flash lifetime. So it's important to kind of keep a track of that. And here I've included the statistics, so I can kind of see exactly where it's being problematic and go, actually, it's the total logs. I'm being a little bit spammy in my logs, or is it debug messages? And you can kind of see the counts here. So I can then react accordingly and then have a bit of like a debug and get fetch logs from it and going, okay, it's this service and all that. But you can do all the statistics. It's up to you to kind of then publish them. Then the last demo, I just want to kind of showcase the scenario when you're looking about trying to publish data in different formats. So this is both touching the nice COMLocity MQT service. So if I just change the events screen, so still same device, and I have events on the right side, and then I'm just going to invoke some of these events via the command line, so the shell feature. So the first one, I'm just going to publish a JSON event, but I want to enrich that data. So on the right side, we see actually we've got two events coming in. That's actually on purpose. In real life, you would say, hey, I only want the, the enriched event. But this is more just to showcase the differences. So let me just make that bigger. So this is the plain event, which doesn't have any data enrichment. And this one has data enrichment from two levels. So first of all, you have let's say a TED sequence that you want to kind of some counter to increment something over time. So every message, it will increment by one. And then you also have this field, which is, so that's being published over MQT. And the next part is that the thing on the server is interpreting this message from the MQT server and then also doing an additional enrichment level. So you can kind of do it at both levels, either on the device and in the cloud, and it's the same concept. So that's a really powerful mechanism because you can kind of then put your logic where it is then appropriate to you. And in the end, before it goes to the COMLocity data model, you've done all your enrichment, and then you create the event. That's it. So it's all quite simple to do. and you can be flexible in your data format. And the last one, in the few remaining minutes that I have, I'm going to send another event, and this will not look fancy whatsoever. Because going, well, you just created an event, right? Who cares? So let's have a look actually what's happening in the background. So I'm just going to use the cloud HTTP proxy so I can have a nice terminal, because the magic is really not, well, it's hidden, so you don't really know that it's doing a lot of wonderful things. So here I'm sending a message, and it's actually encoding this into Protobuf. So this is why here, this is just the rendering on the command console, because we can't render binary because it would just look awful. So we added that in the sub command that it will also go, hey, if you encounter non-UTF-8 characters, then show that as base64. But this is actually sending it to the MQTT service with this payload. So I'm halving the payload size, because this is like 31 bytes I counted. And then in comparison, just sending the message normally, that would be like, I don't know, 76 bytes. So it's half the size, which is a really great improvement. And as the last test, so all of this demoed, hopefully is enough interesting. Just go, oh, wow, Flow is awesome. How do I install the next version when it comes out? And all of this was done using the MQTT endpoint, like the new MQTT service endpoint from Common. So one connection doing all of the processing, fantastic. Yeah, so I hope everyone's also excited like we are for the next release. And we're really looking forward to any kind of feedback that we have from it. And I believe at the end, I'll be open for questions.